applications involving expected value. So let's look at that one problem that was in yesterday's assignment. You draw a card from a deck. If you get a red card, you win nothing. If you get a spade, you win $14. For any club, you win 28, plus an extra 10 for the ace of clubs. First thing we want to do is come up with our distribution model. So I have red card. How many red cards are in a deck? Let's see, red. Oops. Black, red. This is my variable x. Drawing a red card. How many are there?
13.
What's that? 26 out of how many? 52. So about half of them, right? So 1/2. This will be my probability of x. Next, well, actually, that means I win nothing. So sorry, that is red, and I do not win anything. So that is $0. If you get a spade, you win $14. So my x is going to be 14. What are my chances of getting a spade? How many spades are there? 13 out of 52. So I have a 13 out of 52 chance. For any club, you win 28 and an extra 10 for the ace of clubs. So let's look at here. Ace of clubs, this is going to give me an extra 10. So that is going to be 28 plus 10, that's $38. What are my chances of getting just that one card? 1 out of 52. And then the rest of the clubs, because I got to take that one out, right? Is a special case. I get 10 more dollars, gives me $28. And how many clubs do I have left over after I take that one ace of clubs out? 12 out of 52. So this was the tricky part right here, knowing you had to take this ace of clubs out and just leave you with the 12. Hopefully you saw that. So here's my distribution model. I need to find what? Well, let's just go ahead and find the expected value. What does it say? So stats, edit. If you have anything there, just go ahead and just delete it. My L1, I'm going to make that my winnings. So I win 0, 14, 38, and 48. My L2 is going to be my probability. So probability of 0 is 1/2. Probability of 14 is 13 over 52. Probability of $38 is 1 over 52. And the probability of 28 is 12 over 52.
It's 28, not 48. 38.
Oh.
28.
Right, 28. All right, so there's my distribution table. So stat calculates to calculate that expected value. Y1 vars. I need to make sure list 1 has L1 and frequency list is L2. Let me go down to calculate and tell me what is my expected value. How much am I expected to earn on average?
10.69.
10.69, yep. Expected value is the same as mean or average, which is this number right here. So about $10.69. So my EX is $10.59. Since we also talked about standard deviation, what is my standard deviation?
11.97.
Yep, 11.97. So I'm expecting to earn about $10.69 on average, give or take 11.97. Somewhere around there. Next, let me have you work this out, and then we'll come together and solve it as a class. A couple plans to have children until they get a girl, but they agree they will not have more than 3 children, even if all are boys. Assume that the probability of having a girl is 49%. Create a probability model for the number of children they'll have. Find the expected number of children. And find the expected number of boys they'll have. With these, if you don't set up the probability model, then you're probably not going to answer it correct, right? So let's make sure we have the model set up correctly. 49% chance of having a girl, which means what is my percent chance of having a boy? 51% chance. All right. Three things are going to happen here. My variable x is here. I'm going to have one child, two child, or three children, right? I'm going to stop at 3. So here's my probability of each of these happening. If I stop at 1, what does that mean? What happened? If I just stopped at one child, what happened?
You had a girl.
I had a girl, right? They agree to have children until they have a girl. So that is going to be 0.49. I stopped at 1 because it was a girl, and I had a 49% chance of it being a girl. If I stopped at 2, what does that mean that happened?
You had a boy then a girl.
Very good. I had a boy and then a girl. How can I calculate the probability of that happening? Multiply, right? A boy and a girl. Remember, or is at, was it? Yeah, whatever. So I had a boy. Actually, you can work out the tree. So I had girl was 0.49. Boy was 0.51. Had a boy, it's not a girl, so I need to start over. Girl, that's still 0.49. And then boy, still 0.51. If I had 2, that means I ended here, right? And again, with our tree, we should multiply across. So I need to multiply 0.51 times 0.49, which is what? .2499. 0.2499. Okay. And if I had 3 children, that means what happened?
Boy, boy, girl.
Boy, boy. Well, either way, they're not going to have more than 3, right? So either way, they're going to stop. Doesn't matter if it's a boy or a girl. But to get here, I need to multiply boy times boy, correct? I don't care if it's boy, boy, girl, or boy, boy, boy. I just know that when I got to 3, this happened. So I need to multiply boy 0.51 times 0.51. So 0.51 times 0.51 is 0.2601. This is the tricky part because I know you probably want to also multiply a girl, but it really doesn't matter the third child because they stopped at 3 children. I just know the scenario to get there was a boy, boy. So that's what we're multiplying. So here's our probability model. If you didn't have this completed or correct, go ahead and type this into your calculator to find the expected number of children. So stats, edit. Let's delete what I have in there. I'm going to have 1, 2, and 3. Probability of 1 was 0.49. 2 was 0.2499. And 3 was 0.2601. Stats, calculate, 1 bars, list is L1, frequency list is L2, and calculate. So, what is their expected number of children? How many can they expect to have? 1.77, yes, 1.77. Now that doesn't make points.
Yeah.
That doesn't make much sense, does it? Well, maybe they had abortion or miscarriage. No, I'm just kidding. So about maybe kind of leaning towards having 2 children, right? So we can kind of round a little bit because 0.77 of a person doesn't make sense. But looking at my standard deviation, we can say about 2, right? Of course, in Connect Math, you'll probably want to leave it as 1.77, but looking at my deviation of a 0.8, looks like it's leaning more towards 2. So I could say they can expect to have how many boys?
2.
Not 2.
Oh.
That means that this means
Oh, just
about
kidding.
2 means they stopped at 2, so they had what? About 1 boy, right? Give or take. Could have stopped because it's leaning more towards 2 than it is 1. I would say they can expect to have at least 1 boy. All right. Next one. An insurance policy costs $150 and will pay policyholders $11,000 if they suffer a major injury, or $4,000 if they suffer a minor injury. The company estimates that 1 in every 2001 policyholders will suffer a major injury, and that 1 in 503 will suffer a minor injury. Create a probability model for the profit on a policy. So let's start with this model. I'm going to have 2 types. People who have no injury, right? People who have a minor and a major. So let's see, no, minor, major. My X is going to be how much is being paid out. So let's see, what was it asking for the profit on a policy. So if nobody was injured, how much did that insurance company make? Think about it. If nobody was injured, how much did they make? Did they lose any money? Did they have to pay anything out? No. So, did somebody pay them? Yeah, the $150. So they made $150. They didn't have to pay anything else, so they get to keep that $150 because there was no injury. Minor injury. Somebody paid $150. They got a minor injury, so they had to pay out $4,000. So what was their profit? They lost what? $4,150. That's how much they received from the customer. Customer got minor injury, so they have to pay them $4,000. So let's say minus $3,850. See how that works? We're looking for how much did they profit on the policy. Well, they did not profit at all. They only got $150 and they had to pay out $3,850. So what does that make for the major? How much profit did they make on the major? Very good, negative $10,850. They received $150, but that person had a major injury, so they had to pay them $1,000, which is negative $10,850. Now let's find our probability of that outcome. Well, I don't have any information on no just yet. What is the probability of a minor injury? What was my probability on a minor injury? Yep, 1 in 503. What is my probability of a major injury? 1 in 2001. How do you think we could find the probability of no injury? If you can remember one of our rules with probability models.
Do you add them?
All of this must equal to what? 1. Okay? All of this must equal to 1. So I'm going to add these together and then subtract from 1. That should give me this one, right? So let's see. 1 over 503 plus 1 over 2003. 2003, right? Oh, 2001. 2001 minus, actually, I'm going to add that together. Minus 1 gives me a probability of 0.9975. I'll stick with that. 0.9975. Most my calculator is nice enough to put it in a fraction. Nope. So everybody see how I got the no injury? That one unknown. But I do note that the whole thing should equal to 1. So add these together, subtract from 1. There is my probability of unknown. Your probability table should look like this. Let's calculate. Stats, calculate, 1 var, enter. How much does the company make per person? Your what? $136.55. Yep. And this seems pretty accurate too. If everybody wonders, wow, insurance company had to pay out this guy millions of dollars. How can they ever stay in business? Well, they make money off of everybody. The more you have, the more you can make. The more customers you have, the more probability of those customers not paying out or having to get paid out. So, and what is my standard deviation? 303. Something, right? That's a pretty big standard deviation. That means, give or take, I could make a lot of money off of each customer or no money at all.